Alright, ladies and gentlemen, I don't know if you can tell by my voice, but I'm not feeling very well today, so I came in early to make this video for you so you could still do math while I'm gone. So we're going to go over Chapter 2, Section 1, and this video covers domain and range and how to tell if things are functions or not. So I separated my paper into two sections. You don't have to do that, but I was just trying to conserve paper to get stuff all in the video. And you may have noticed that I've already written a lot of stuff. That was because I was waiting for my iPad to charge, so instead of wasting time when I don't feel well, I went ahead and got a little bit ahead of you. So if you need to pause the video and write down this stuff, that would be great, but otherwise just follow along with me and I'll talk about some of it while I go through it. So domain are your x values. They are the inputs into your equation. Usually they're the numbers that you pick and then put into the equation. They are also called the independent variable because you can choose them. When you're trying to get the domain from a graph, you scan from the left to the right, so you would put your pen or pencil on it and scan from left to right, and we would write our domain using inequalities, and we'll do that here in a little bit. What we're going to do first, though, is this example over here. We are going to use roster notation because it gives us a list or a set of ordered pairs. The next thing we need to talk about before we do that example, though, is range. Range is your y values. They're the outputs or numbers you get out once you choose the x and sub it in and simplify your equation. That's what you get out. They're the dependent variable because they depend on what you choose as your input, your x, and what your equation says, so they will depend on those things, and they'll be your answer, your y. From a graph, you scan from bottom to top and use your inequality notation. Then for our first couple examples, we're going to use roster notation, and anytime you're given a list or a set of ordered pairs, you would use roster notation. Then how to tell if something is a function or not. In order for it to be a function, each x can only go to one y, so you couldn't use it more than once. Like you couldn't have -2 go with 1 and -2 also go with 5. That would make it not a function. X values cannot be repeated. Again, they can only go with one y and they can't be repeated. And if you have it graphed, for us visual learners, this is nicer, it must pass the vertical line test. And sometimes I'll go ahead and, if I've been given ordered pairs, I'll graph them if I'm not sure, and then use the vertical line test. Because I'm a visual learner, it helps me. When you have a graph, it's a function if you can draw vertical lines anywhere on the graph and they only hit the graph, the function that you have graphed in one spot. If they hit it in more than one spot, then it is not a function. So pause your video, go back, get all of that stuff written down, and then we'll move on to this one when you're ready. So when you're ready, this example says I have ordered pairs -3, 0, 0, 7, -2, 4, and 4, -5. Then it wants to know what the domain is. Well, here's where I'm going to use roster notation. So to use roster notation, after it's asked me for domain, I draw this little squiggly guy. Kind of looks like a bird when you were little, you know, sideways when you drew those birds. Anyway, if you don't know what I'm talking about, forget it. Domain, like we said, is the x values, so all my x values, remember, come first. So I'm just going to write them. So this is the x value at this point. The x value of this point is 0. This one is -2, and this one is 4. So those are all my x values. Then the range, again, the range is the y values. So in this ordered pair, my y value is 0. In this ordered pair, my y value is 7. There it's 4 and -5. And close that up. That's all you have to do to give me your domain and range in roster notation. But then it wants to know, is it a function? So this takes a little bit more effort. So we look, -3 goes with 0. Do I have -3 going with anything else? No. 0 goes with 7. Do I have 0 as an x value going with anything else? No. -2 goes with 4. Do I have -2 as an x value going with anything else? And 4 goes with -5. Do I have 4 going with anything else? No. So since no x values go to more than one y value, I can say yes, it is a function because no x values repeat or are used more than once with any given y value. So no x values repeated, so yes, it is a function. Now sometimes instead of drawing or writing out your ordered pairs, you'll be given something that's called a mapping diagram. And this is a mapping diagram, and it's different because it uses your domain here in this first box, and this is your range in the second box. And then if you needed to write these as ordered pairs, for instance if this were a number, you would write this one first and then that one second. So it would be cat, 3 or dog, 5. But you use the arrows to tell which one goes with what. Okay? So same thing here, our domain. So our domain is everything in this box. Cat, dog, to, of, from, and given. Remember to pause the video as often as you need to write down this stuff. Sorry I wrote it down early, but like I said, I was waiting for my iPad to charge. I didn't want to waste time. So then our range comes from the second box, 3, 7, 5, 6, 2, 4, and 8. It's a terrible looking 7. And you'll have to check MathXL. I didn't look. I don't think it would want it in any type of order, but make sure you're reading that light blue writing and just double checking to make sure it doesn't want it in any sort of order. So then, is this a function? To tell if these ones are functions, you look at each domain and basically you just see if there's more than one arrow coming from it. So since cat only has one arrow, dog only has one arrow, to, of, from, and given, they all only have one arrow, then yes, it is a function. But for example, if cat had also gone to 7, like let's pretend there was an arrow here, then cat would be used twice and it would not be a function. But since that's not the case, is it a function? Yes, no, domain values are used twice or more than once. None of them get used more than once. So yes, that is a function. Alright, now let's look at some graphs. Oh, that tore off nicely, I was afraid. Okay, let's look at some graphs. So up here at the top, and again, pause if you need to catch up. I have this all written out already. This first graph is a parabola. It's a U shape. I hope you remember that its function name or its equation is x squared. If you don't remember that, don't worry. We will talk about that a lot this year, and you will know by the end of this year. So, in order to do domain, we have to scan from left to right, and we're going to use inequality notation. So I start here on the left and I scan. And the first place I would hit my graph is this arrow pointing up. Okay? So this arrow points up, but it also points out. This graph would continue on forever towards the left. That means I will start my graph at negative infinity. So as I scan from the left, if the first thing I hit is an arrow, that means I need to use infinity. And since it was on the left side, it's the negative infinity. Now since this is domain, hopefully you remember that's x values, so I'm going to use an x here. And then I need an inequality sign. I would either normally here use less than or equal to. And the reason I'm only going to use less than is because negative infinity is less than x. If I was going to use less than or equal to here, that would mean that x could at some point be equal to infinity. And since that's not possible, then you just leave that or equal to off and just make it less than. So let's keep scanning. As we scan to the right, the last thing my pen touches is another arrow. So that means infinity again. And if you can't draw infinities, just turn your paper sideways and draw 8s. Then the range is a little bit different. This I'm going to scan from the bottom to the top. Notice I have another negative infinity down here, so scanning from negative infinity to here. But here on my graph I did not hit an arrow. So since I did not hit an arrow, I'm going to use the value, the y value of this coordinate point. So if you know this coordinate point is 0, 1, the y value then is 1. So 1 is where my graph starts on the y from bottom to top. So I scan, I'm looking to see where the y values begin. So my y values start at 1. Is my graph actually touching it? Yes, so that gets a less than or equal to. And then since this is range, I use a y. And then as I scan up to the top, the last thing my pen would touch would be arrows. So that means I need an infinity, and again, not an or equal to. So I used an or equal to on this number because it actually touched the 1, but not on infinities because it can't touch. Now, to tell if it's a function on graphs, we use the vertical line test. So if I can take a vertical line, let's use this pink thing. If I can take a vertical line and touch my graph in more than one spot ever, then it's not a function. But since I couldn't, then yes, this is a function. So is it a function? Yes, because it passes the vertical line test, which means that none of my x's got used more than once. Okay, on this next one, this is just a nonsense graph. It really is not, I don't know that it even has an equation, I just made it up. Well, or Mrs. Miller actually made it up. So same thing, to find the domain, you scan from the left, and the first thing I hit is an arrow, and since I was coming from the left and that's a negative direction, that means negative infinity. Scan to the right, the last thing I would hit is an arrow, so that also means infinity, and since it's domain, I use my x. Now to do range, same thing, bottom, arrow, top, arrow. So that means I'm going to be going from negative infinity to positive infinity, and this time using a y. Now this time, to do my vertical line test, I'll grab this pink thing again, I'm going to go through here, and I'm going to try this vertical line right here. So if I draw in that vertical line right there, do I hit my graph more than once? Well, it looks like I hit my graph here, here, and here. So did I hit my graph more than once? Definitely. So since I've hit my graph more than once, this is not a function, because this x value got used with at least with those 3 y values. So make sure you're using your vertical line test. If you need a ruler, or use another piece of paper if that helps, or if not, just use your pencil. Okay, this next thing I'm going to talk about is function notation. This is a little bit different. How you've been used to seeing this stuff is y equals 2x plus 3. All we're going to do is take out this y and give it another name. Its new name is f of x. So these parentheses get read as of. You read it as f of x. So this says f of x equals 2x plus 3. And how you would find this when you had y equals 2x of 3, if I asked you to find y when x equals 5, you would know what to do, correct? You would do y equals 2 times 5 plus 3, so that would be 10 plus 3, or 13. So it's the same process, it just looks a little bit different. So when you're using function notation, and I ask you to find it, you would say, I would ask you, instead of saying when x equals, I would put it like this, f of 5. So this is my equation when x is in there. Now I need to write it when 5 is in there. So all that means is I'm going to take everywhere there was an x and put a 5. So it'll be 2 times 5 plus 3. So f of 5 is also 13. So if I were going to graph this ordered pair, it would be 5, 13. So it's the same process, it just looks a little bit different. So you take out the y and replace it with this f of x thing. Okay, so let's work on one of these that's a little bit more challenging. So here's my equation. This one is g, not f. They can have all different names, just like people. You can name them any letter you want. Usually they're named F, G, and H. is what is normal, but you can name them other letters too. So this, you just wouldn't want to name it obviously x because it's already got an x in it. But g of x equals negative 1/3 x. So we're going to do a few things with that. First, I want to find g of 7. So hopefully you remember that this means I'm going to take out this x and replace it with a 7. So this is going to be negative 1/3 times 7. So negative 1/3 times 7 over 1, and then we multiply straight across. That's going to be negative 7 over 3. So g of 7 equals negative 7 over 3. So on the graph, we would see the ordered pair, or if we were graphing this, we would plot the ordered pair, 7, negative 7/3. Okay? Also, we could do even a bigger number, find g of 36. So same thing, negative 1/3. Actually, why don't you pause here and see if you can do this one on your own. Let's see what g of 36 is. Negative 1/3 times 36 over 1. So I have negative 36 over 3, which is, oops, I forgot to close that parentheses. 36 divided by 3 is negative 12. So on the graph, I would have the ordered pair 36, negative 12. Okay, so that's how you find it if you're given the x, or the independent variable, the one you get to pick. If you're given the dependent variable, or the y, it's going to look a little bit different. Instead of this x changing to a number, it's going to stay an x, and it'll tell you what it equals. So it tells you what the y, or the g of x, is, and you need to find x. So how we do this is it's just substitution. We replace the g of x with our number, in this case it's 10, and we solve for x. So notice I already did that. Sorry, I jumped the gun. So you would take this g of x out from this equation up here. We're still using this equation up here. So instead of writing g of x, I wrote 10, and then I have my negative 1/3 x, and now I need to solve for x. So I don't really want to divide by a fraction, so instead I'm going to multiply by its reciprocal. So I'm going to multiply by negative 3 over 1. So those cancel, and all I've got on this side is an x, and negative 3 times 10 is negative 30, so I've got negative 30 equal to x. So on the graph we would see, and notice I already had the y value in here because that's what it told me g of x was, and you have to try to remember that g of x is just your y values. So on the graph we would see negative 30, comma 10. Or we would point that graph that point, left 30 and up 10. So good luck on your assignment, and if you have any questions, go next door and see Mrs. Miller, or you can go to room 205 and see Mr. Kirshner.